We've all been there. You're cooking your favourite meal, but you just can't find the right spice. Well, that's what we're going to solve today, because we're going to build a voice-controlled spice rack. Let's start designing it. So the base of the spice rack is going to be this chunk of wood with a hole cut in it for the servo. So the servo is going to slide through that hole, and onto the servo is going to be a GT2 pulley, and there'll be another one at the other end with a belt wrapped around them that the spices will rotate around. So we've got these two sections which tension the belt, and there'll be a little threaded rod with some nuts on it to tension it. Then this clamp that will hold down the other end, and finally the spice holders, which will be attached to the belt and can hold the spices. Send that to the 3D printer and we can put it together. While that's printing, we'll take a look at training the voice recognition model. So in order to train a voice classification model, we need some data. So I've gone and recorded myself saying 15 different spices, not 15 different spices, 9 different spices 15 times, and then one wake word 15 times. So this gives us nine different classes that we want to classify. So then we load the data in using SciPy, and then I'm downsampling it from 44 kilohertz, which is what the microphone records, to 16 kilohertz to try and reduce. I was getting some high frequency noise, so that's to try and remove that. So then the signal that we get looks, that's the wrong script. The signal that we get looks a bit like this. So this is one of the words, and you can see the bit where I'm saying the word. Here's a different one, and we can look at a few of those. So once we've got that, we can build a spectrogram, which is it's like a visual way of representing the frequencies in an image as time goes along. So they look like this, and you can see there's like hardly any high frequency stuff, but there's some lower frequencies around here, and obviously frequency up the y-axis and time along the x. And you can see these are all different for the different samples that I've taken. So then once we've got that, I'm removing all the high frequencies, just the low ones, because there was nothing in the high frequencies, appending it to my list of training data, and then adding the label in. I can then shuffle the data and split it into training and test sets. And then the key bit here is the fact that because a spectrogram is basically an image, we can use a image classification model, so a convolutional neural network. The exact architecture here isn't really that relevant. It's just pulled from a TensorFlow example that I'll link below. So we can build that model and then train it with the data that we've pulled in above. So then when we train it, we get, so this is it training, takes a few seconds, and then here we go, we can see the training accuracy and the validation accuracy. So the training accuracy you'd expect to go up, and the fact that validation accuracy is going up as well, it's good because that's data that it hasn't seen during the training phase, so we know that it's definitely learning something that's hopefully useful. Now we've trained our model, we can move it over to the Raspberry Pi where we're going to do a prediction. And I've written a little script that will listen to the microphone until it hears something, record for 2 seconds, and then pass it over to our neural network. So we can run that now. Turmeric. And you can see the output for the neural network was the label turmeric, so that was correct. We'll try it once more. Garam masala. sage, and the output of that one was sage as well. As you can see, the predictions aren't perfect, so I might go back and add some extra training data and see if that improves things. So now everything's printed, we can start putting everything together. So here's the chunk of wood that I have. This is the only piece of wood I could find in my flat, and it's the corner of my girlfriend's desk, so hopefully she doesn't notice it's missing. So into that we're going to pop this servo, and I've pulled the potentiometer out of this servo so it just continuously rotates. Now it's all together, I just want to quickly check the motor's powerful enough to move all the spices before I add the finishing touches. Now it's together, we've got two little extra bits to put in. So I've drilled 2 holes at the front and then 2 holes up from the bottom that hopefully you can see if I twist it. Yeah, 2 holes up here that meet the other 2 holes, and into each of those I'm going to pass, one's going to get an LED to show when it's listening, and one's going to get an LDR so that we can tell when the cupboard door's open. Here we have the completed spice rack installed in the cupboard, ready for a test. Okay, spice rack. Okay, spice rack. Time. Okay, spice rack. Okay, spice rack. Oregano.